Good morning. For our deep learning project, we have focused on the challenging of detecting skin cancer, a serious health issue where early detection is crucial for effective treatment. Right now, doctors mainly rely on visual checks, which can sometimes miss early signs. To help with this, we have developed for deep learning model that analyze images of skin lesions and look for pattern might indicate cancer earlier. We have comparing these model to find out the best one that fit with the best test accuracy. Now let's move into the first model that I have created for the deep learning project. First, I import the necessary libraries and load the CSV file and print the first 5 record with the help of get command. And I have created a folder called dataset and copy all my data into the dataset folder. In there are two folders that contain over 10,000 images of skin cancer, and there are several CSV files that label the data. And in here I have coded to view the labels, and there are uh, 7 labels, and each label contain how much number of data that have. And I have create a graph the distribution of the skill leases classes and view how much it contain the data. And in here I have split the data into X-train, X-test, Y-train and Y-test. And in here also I have import the necessary library to train my model. And first model I have created, that's called hybrid CNN. It contains several convolutional blocks that are, first one is convolutional block, the second one is identify block, the third one is dense block, and the last one is transition block. With the help of convolutional block, it helps the model to detect important feature in the images, like edges and textures. In identity block, it inspired by the ResNet and help the model learn better as it get deeper. The dense block, borrowed from the DenseNet. These allow information to flow more easily through the network. And the last one is transition block. It reduces the size of the data as it moves through the network and making it more efficient. The model is end up with fully connected layer that make the final decision about which class the image belong. And the compile, I use optimizer that is equal to Adam, and the loss function is sparse categorical cost entropy, and the metric is accuracy. In the training process, I pass X train, Y train, and epochs is equal to 20, and validation dataset is equal to X test and Y test. After model getting trained, I have used tabular format to view the accuracy, and the test accuracy is 76.55, and the test loss is 1.1699. And also I have viewed the training and validation accuracy via the graph, and this is the graph that I have gained. And also I have plotted a graph that visualize the training and validation loss. Let's move to the second model that I have created. As mentioned in earlier, I have loaded the CSV file and view the data, and also I have viewed the label as well, and I have viewed the distribution of skin lesion classes. And if I go to the implementation code, I have used ReLU and softmax as the activation function, and the Adam as the optimizer, and the sparse categorical cost entropy as the loss function, and the matrix is accuracy. And training of the efficient net model, I have passed several data. Train resize data, Y train, validation, and the epochs is equal to 10. And after getting trained the model, I use tabular format to view the accuracy. The accuracy is equal to 94.59, and the test loss is 0.16. And I use graph to view the training and validation accuracy. And this is the graph that I have gained. And also I have plotted a graph to view the training and validation loss. And also I have plotted a diagram to view the training and validation lost. And this is the diagram that I have gained.
In this part of our project, I work on a model called Deramonate. The purpose of this model is to classify skin diseases or conditions based on image of skin lesions. Skin problem can be very serious and it's important to detect them early. The goal of Deramonate is to help doctors by identify potential issues through image recognition. So, what I did, I used a dataset of skin images. In this case, the CNN looks at features like the shape, color, and texture of skin lesions. I create several layers in the model to make it better at the recognition this pattern. The diaper layer helped to model learn more complex features like while the early layer handled simple details like I split the dataset into two parts, training and testing. The training is used to teach the model while the testing set check how well the model is. During training, the models look at each image, tries to guess the correct label, and improve over time by adjusting itself based on mistakes. After training, I test Deranet on new images it had seen before. The model became quite good and recognized different skin conditions. I also used accuracy and loss matrix to measure its performance, and the results show that the model could be a useful tool for detecting skin problems. So next I work on more complex model called ResNet 50. This model is a popular deep learning architecture that has been used in many images classification tasks. ResNet 50 is known for being deeper the simple CNN, and it's used a technique called residual learning, which helps solve some problem with training deep network. So what I did, ResNet 15 is pre-trained model, which means it has already learned recognize wide range of objects from large dataset like ImageNet. I choose use ResNet 50 because it can save time and improve accuracy by using this previous knowledge instead of starting from scratch. So I fine tune it for my specific task. So and transfer learning is when we take a pre-trained model and adjust slightly for new tasks. In this case, I use REST 15 and retrain it on new dataset. Transfer learning is when we take pre-trained model and adjust it slightly for new tasks. In this case, I use ResNet 50 and pre-train it on new dataset. The first layer of ResNet 50 remain mostly the same since they handle basic features like edge and colors. I only change final layer to help the model better recognition the specific image and I was working with. So during the training process, the model learned to classify image based on the new dataset I provide. It used its previous knowledge from ImageNet and applied it to this new problem. The training was efficient because the model didn't have to learn everything from scratch. So, so after fine tune, I test ResNet 15 on a new image and it performed well. The accuracy was high and it could classify the image correctly. I compared its performance with the Deramonate model, and while both did well, ResNet 50 was fast and slightly more accurate due to its advanced architecture.
After implementing all four deep learning models, we compare the test accuracy. The models are hybrid CNN, ResNet, EfficientNet, and DermaNet. And we have plotted the diagram with the help of matplotlib. And hybrid CNN gain 81.84%, ResNet gain 27.70%, efficient net gain 96.22%, and DermaNet gain 97.22%. Out of four deep learning model, DermaNet is the best model. Thank you.